Hi everyone and welcome back to the channel. Now first of all, a massive thanks to all of you who sent me emails on my personal email address and on my Instagram account about technical stuff. I do read them all. I try and get back to you as soon as I can, but I don't just want to give you like one-line responses, and more often than not actually I end up not replying because I don't have the time to write everything I want to write. So what I thought I'd do is cluster those questions together and my responses and make this little video, and I'm going to do a series actually of like Q&A on the technical questions that I receive from you guys, and because it might make interesting viewing for everyone else watching anyway. So I'm going to start with a few questions in this video. There's way more to get through, and actually the oldest questions that I've been sent are probably going to end up in the last video because stupidly I've gone from newest first. So oh well, that's the way the cookie crumbles. Anyway, we're going to start with the really easy questions to like get us in the groove and get us underway with the anorak tech stuff. It might get a bit anorak-y later, so I suggest grab yourself a nice cold drink. So before we get into anything too bicycle related, I'm going to answer a general question on engineering and engineering careers. Now, a guy sent me an email, a guy called Ivan from Croatia. He's a graduate mechanical engineer. He's living in London and he's really struggling to find a job. Okay, sign of the times, it is hard to find jobs at the moment. Everyone's going through the same thing. Don't give up. And he said, you know, I'm specialising in mechanical design. I'll get my master's in June. I've been trying to apply for jobs early, which is great. Yeah, have a plan before you graduate. But I'm really struggling to get anything or have any bites. Can you offer me any advice? Well, my background's kind of in the aerospace and automotive industry in the UK. And Ivan, I think you're in the wrong place. So by all means, finish your degree in London at your London university, wherever you are, but there aren't any really aerospace or automotive or manufacturing design jobs in London. London is a very expensive place to live. It's a services industry. That's what the work is. Unless you want to get into civil or construction, you need to start looking outside of London. So, and this applies to wherever you live. If you're from the States, if you're from Germany, if you're from Australia, you'll probably find those big CBDs, those very expensive cities to live in, don't really have much in terms of engineering jobs unless it's civil or construction, which most of you viewers probably aren't into. So you need to find that niche area of industry in your country, and as a graduate you can't be picky, you have to go to the work, right? When you specialise a bit older, you can move around and let the work come to you a bit if you're lucky, but now you need to start looking in those areas. So Ivan, if you're in the UK, I would recommend you look in the Thames Valley. Right, so that area between London and Oxford is a very, very niche hub for the kind of UK automotive design consultants, aerospace companies, small businesses that will really cherish young graduates. Another place to look is like Surrey. You've got a lot of automotive down there, and between the Thames Valley and Surrey, you've got pretty much all the F1 teams in the paddock. So if you wanted to get into motorsport, apply to all of those teams. You've got McLaren, you've got Williams, you've got Renault, you've got pretty much all of them down there. Yeah, they don't pay very well. F1 doesn't pay very well, and you're probably going to work weekends. But there's loads of other little companies that supply F1 teams. You've got electric car companies cropping up all over the place in those areas. If you're more orientated on aero or marine, look at Bristol, look at the south coast. But my advice to you and my advice to anyone is get out of the big CBDs if you're a mechanical engineer, unless you want to go into you know, civil or construction. Now this question came through on Instagram, and it's one that comes up a lot when I talk about wheel builds, custom wheel builds. Do I go for J-bend or do I go for straight pull spokes? Well, I see absolutely no reason to go for straight pull spokes. Always pick J-bend. Number of reasons. They don't spin when you're trying to tighten them. They're more readily available from your local bike shop when you break a spoke, and it just makes the hub flange design just a bit like simpler. It's a less messy machining. The hubs tend to be a bit cheaper if they're a J-bend design flange. It's a much simpler machining. It's just a straight flange with holes drilled in it, and they're much easier to lace. Like, it's much easier to get in your head like which spoke goes where to the rim, especially when you're doing 2-cross or 3-cross. So every time pick J-bend. Some people say that the J weakens the spoke. Well, I've never ever snapped a spoke or seen a snap spoke in reality that snaps at the J. They always tend to snap where the section is thinner, like the aero profile section. So if you're using a high performance spoke like a Sapim CX Ray, pick a J-bend spoke. Everything's nice all the way around. Now, a bit more anorak-y, but we're going to stay with wheels. Javier recently emailed me. Sorry, I don't know where you're from because you didn't say, but you sound Spanish. He asked, I'm looking at buying some new hubs. Do I go for a hub with a steel axle or do I go for a hub with an aluminium axle? And he actually specified the materials. So The steel axle hub that he's thinking about is a chrome molybdenum steel. So if you're American, that's SAE 4130 chromalloy. You guys say chromalloy. Or do I go for 7075 T6 aluminium? Now, 7075 T6 aluminium is actually pretty strong for an aluminium. It has, you know, a similar yield strength to a lot of steels out there, but it has a much lower hardness than the chromalloy steel, the 4130 steel. So I always say, if you're putting anything inside bearings, like an axle that runs on the inner race of a bearing or the outer race of a bearing, pick steel. The caveat is, if the hub axle is a very hard press fit inside the inner race of the bearing, then I would say you can pick a softer aluminium, pick a softer material like aluminium, especially 7075 T6, although it is quite strong and you can put a hard anodized coating on it. But if it's a sliding fit, if it's a running fit on the inner race, always go for steel, like I would a crank, like a Shimano crank. That's why I always pick Shimano cranks, because that's a slide fit through bearings. Okay, the bearings have got plastic top hats, but it won't fret and it won't gall like aluminium. The only caveat, like I said, is if the hub axle is press fit through the inner races, then you could get away with 7075 T6 and a hard anodized coating, like one of my favourite road hubs, the DT240. Well, one of my favourite hubs all around. I've got it on my mountain bike. The DT240 is a 7075 hard anodized axle, but because it's press fit on the inner races, it doesn't fret and it can't under rotate and it can't gall. So it kind of depends on the hub design. If you're unsure and you're not bothered about weight, always go for steel. Now this is quite an interesting one that I've been meaning to reply for a long time. Richard from Slovakia emailed me and sent me some pictures of his S-Works Tarmac SL6, or it might not be an S-Works, it's specialised. Tarmac SL6, took it to the bike shop for a service, noted a crack by the top of the seat tube where the split in the seat tube is, where the clamp goes round. And at first I thought, oh yeah, someone's over tightened that, or tightened the clamp without the seat post in, and the stress has caused it to crack at the bottom of that slot, that compliance slot, which is there to allow deformation. And or it's fallen out of the work stand and landed on that carbon leaf without the seat post in and cracked. And I thought, that's just bad luck, because you rarely see those cracks. But on further inspection, if you look at the pictures, the large hole at the bottom of the milled slot is there to be a stress reliever. It's to stop cracks propagating out of that slot. Now if you look closely at the pictures, and I only noticed this on the second look, the stress relieving hole is offset, and it's not central about the slot. So it's not doing any stress relieving on one side of the slot, and that is where the crack is, and that may be causing the crack. That stress relieving hole, just because of bad tolerances, bad machining, bad QC, it's slipped through the net and it's not actually doing its job, and repeated clamping of that slot could have caused that stress razor to propagate a crack. I can't be sure, I don't know the history of the bike, I don't know if it's been dropped, but that bike should never have got through QC. So if they're bothering you with a warranty claim and saying you can't warranty this, you know, it's not our fault, say, well, that stress relieving hole isn't doing its job because it's not central about the slot, and that's why the crack's probably propagated. So I'm really sorry, Richard, for getting back to you so slowly on that one, but I actually took some time to consider that failure, and I think that's what's happened. So go back to Specialized, go back to the bike shop and say, actually, I think this is a warranty issue. That milling of that slot on that stress relieving hole is pretty terrible. Now I had a question from a guy called Robin on an email who asked me about shorter cranks. He's been suffering from quite bad knee pain since riding more, and you saw my video on the 4-bar analysis, so the 4-bar analysis of the leg and the crank system, which is an approximation, but I've got a very long in-depth study on the crank length and 4-bar analysis. And he said, would the shorter cranks help me with my knee pain? Could it possibly open the knee angle at top dead center? So when the crank is at top dead center, could it open the knee angle? Absolutely, yes, it can. It will open the knee angle, it will open the hip angle. If you accompany that with a higher seat, which you can afford to have with a shorter crank, you need to push the seat up a little bit. That will naturally, at top dead center, so at 12 o'clock with the pedal stroke, your knee angle will be slightly more open. Now, why is that beneficial if you're suffering from knee pain? Well, a lot of knee pain in cyclists, and I'm not physio, but a lot of knee pain in cyclists, I've studied some biomechanics, a lot of knee pain in cyclists comes from, it's basically like acute tendonitis. So that can come on through overuse or a sudden surge in your training load. If you go from, you know, 0 to hero and you start riding 300, 400k every week, or training like 10 hours every week, 20 hours every week, it's not uncommon, like in any sport, it's the same as swimming or running, you're going to form some sort of tendonitis. Now, most commonly is like the quadricep tendonitis, which you get at the bottom of the quad, which is at the top of the knee. And why do you get that? Well, when you extend your leg, your quadricep contracts and it basically shortens, and it pulls the tendons that connect to the top of the kneecap. It pulls them over the kneecap, and they run in a groove. Basically, a very simple way to think about it is like how a rope runs or how a belt runs in a grooved pulley. And the harder you contract that muscle, the tighter the tension in the tendon, the tighter the tension in the muscle. So if your leg is bent at 90 degrees and your kneecap is running over this 90-degree bend, if you're pulling the rope that way, which is your quadricep, there is a quite high radial force exerted normal to the surface of the kneecap. That pushes the kneecap into the joint when it's at 90 degrees, and it also pushes the tendons into their grooves and cause a bit of like irritation, inflammation. Shorter crank, opening the hip angle, higher seat can all alleviate that. So that would be a biomechanical way to fix it. The other way to fix it is just think about, are you just not used to this increase in training load, something like that. But shorter cranks for sure will help that problem. You know, it's a very common problem. If you're running the seat too low, you do get that tendonitis right at the top of the knee where those quadricep tendons attached to the patella. And some way to alleviate that is push the seat up a little bit if you can afford to, or shorten the crank. Now, Jason got in touch from Austin in Texas, and he's having a bit of a midlife crisis. It sounds like he wants to get into triathlons, but he doesn't want to buy a TT bike or a tri bike. He just wants a road bike. Fair enough. And he said, I'm stuck between a BMC road machine or a Giant TCR Advanced Pro. Now, before I get into this, Giant should put me on the payroll, because, you know, I plug Giant so much on this channel. They really should put me on the payroll. Anyway, I'm just going to navigate now to his email. So I basically said to him, in my first address, I would go for the TCR. I've had my black rim brake TCR, which is the Advanced Pro 1, I think, back since 2016. I've owned a lot of road bikes, I've owned a lot of bikes, and it's probably the best road bike I've ever owned, and I still own. So why is that? Well, number one, simplicity. For me, the best engineering solutions are always the simplest. Like any good engineering product out there, I'm thinking like Porsche 911, every update is an incremental evolution. It's not drastic, it's not reinventing the wheel, it's perfecting a time-proven recipe. And the Giant TCR is a good example of that. You don't see like drastic changes, you don't see any wacky designs, you don't see any weird seat post designs, you don't see any weird quill stem designs. It's just a small evolution on the last model year design, and it's simple and it's pure. And if you think about performance sporting products or motorsport or automotive, two other desirable traits are quite often low weight and high stiffness. And in engineering, especially when you're talking about like motorsport or sporting products like bike frames, simplicity often goes well with those other two things. It's like a three-headed recipe, and it all kind of goes well together. Simple also tends to be one of the stiffest solutions, and it also can tend to be one of the lightest solutions. If you try to overcomplicate a design, you often lose out either on the stiffness or you lose out on the weight. Whereas simple, and you keep, like especially the bike frame, if you keep it nice round or sort of round tube shapes and a nice simple truss structure, it tends to be very, very stiff and very light. Second reason, well, this might be a bit naive to say, but Giant are probably one of the most vertically integrated companies in the industry. So there's very few conflicts of interest between, you know, marketing, sales, design, production. It's kind of, I wouldn't say all done in-house, because that would be a bit naive, but there's, you know, it's not as if you've got a Western brand going to a factory and haggling down frame prices, or, you know, a warranty department who's not connected to a manufacturing department. It's all kind of more in tune with it's all kind of more in tune with itself. And the third thing I can vouch for Giant is shops. They have shops, right? So if you've got a warranty issue, get in front of someone at the shop. I can tell you from experience, shops don't want you at the counter, at the storefront, at the till, moaning about a warranty claim. And more often than not, they'll sort you out with a solution pretty quickly, and they want to keep you happy. They want to keep you happy. It's so easy for a direct-to-consumer brand to drag their heels, to give you bullshit responses, and, you know, sometimes you even have to join like Twitter to even contact someone at the brand because they don't respond quick enough via email. So avoid direct-to-consumer. Giant have shops. Okay, a lot of them are merchandise shops, but they have shops, and they don't want you in there kicking up a fuss in front of customers. So if you've got a problem, they're probably going to help you out pretty quickly. Anyway, like I said, I've rated Giant way too much on this channel. Let's cover this up. They really should get me on the payroll before I do any more Giant plugging. Now, that's a bit of a long-winded one. Peter has asked me about the load cell project. Now, in a couple of previous videos, I did quick release tension measurement with a load cell I made using strain gauges, an amplifier, an ADC and an Arduino, and I had quite a few emails asking me, can you tell me a bit more about that? Interested in what breakout board it is, what Arduino code I use. I can put a link in the description below, and there's some really good tutorials on YouTube about how to basically get started with load cells and Arduinos. And it's very simple. You just basically need this HX11 breakout board, which contains the analog to digital converter and the amp. You need the Arduino, you need some strain gauges. If you don't want to get into wiring your own strain gauges, you can buy kind of strain gauge load cells that are already wired up, and then you just plug them into the breakout board in a Wheatstone bridge. So I've put a link in the description below, some really good tutorials about that. If you've still got in-depth questions about load cell design, it's something, you know, that's my professional background, please do email me. I had another question the other day, I think it was on Instagram or it might have been email. A guy wrote to me and said, my Campagnolo chain set, the chainring bolts have come loose. Should I be worried about this? Is this a design problem? And to be fair, actually that's quite a rare problem. I've not really heard about that. And it's quite rare now to see actually chain sets that have, you know, 4 or 5 chainring bolts and nuts on there, because they're more integrated now. But I wouldn't say it's a problem. I would probably just say they were under-torqued during assembly, or they weren't Loctited. Now the problem is with short bolts is that short bolts don't really have a lot of stretch in them, so they are susceptible to vibrating loose because there's no inherent spring. And that's why in a car, when you've got your cylinder head or something like that, you have very, very long studs, very long studs. And in general, when you're designing anything with fasteners, you want to have at least kind of 2 diameters of free bolt length that's not in a nut, to be able to stretch when you torque the bolt up. You want some stretch, and that spring in the bolt helps it not come loose under vibration. It helps it not come loose under thermal load, so expansion and contraction like you get in a car. A long bolt has that inherent stretch, and it acts kind of like a spring washer on its own to stop the bolts coming loose. Obviously chainring bolts, because of packaging, are very short. There's hardly any bolt stretch between the bolt head and the nut. So if they're not Loctited or torqued up really hard, they can come loose, but I wouldn't worry about it. I would just torque them up, maybe apply a bit of low strength Loctite, and you're probably not going to have an issue again. Another one, let's get into this. Mark from the Netherlands has asked me about custom spaces for his Giant Trinity Advanced Pro. Now, as you know, I've supplied a lot of you viewers of the channel with 15-degree spacers for the Giant Trinity and the Trinity Advanced Pro to tilt the cockpit and the pads by 15 degrees. That's kind of like my stock machining, which I do. Yes, I will do custom solutions. If you're interested in the custom solution is going to be a bit more because it's going to be a one-off, but just email me. And Mark, I have just replied to email today, so I hope you get that. Tom from Germany said he's got a mountain bike and a road bike, both with disc brakes. The mountain bike disc brakes tend to work really well. They never rub, never gets any sticky pistons, but the road bike disc brakes are a nightmare, and I completely concur. These things on my road bike tend to be a nightmare. They rub, the pistons stick a little bit, and have some thermal issues that the mountain bike just doesn't seem to have. And he specifically said, why don't we see a variable lever ratio on road bikes, which would have a long throw of the piston when there's clearance in the caliper, and when the pads meet the disc, then you get a lower throw but higher mechanical advantage. And in mountain bikes, Shimano do something very similar to that, which is called servo wave, which is basically a variable mechanical advantage lever ratio. But we don't see that, or at least to my knowledge, we don't see that in the road levers. And why not? Well, I think it's probably just a packaging issue. It's hard to fit those extra cams and linkages under the road hood with the shifter mechanism. There's very limited space. It might be nice to see that on the next evolution of Shimano road brakes. We might see it, we might not, I'm not sure. And finally, another little one. Paul from California has had a TCR like this with an ISP. His TCR ISP cracked just below the seat clamp, and he's asking me for my 3D printed cutting guide because he's got his frame replaced and he wants to cut it dead flat. Now, I've got a video of how I cut this because I don't trust those Park Tool cutting guides. They basically have a flatness tolerance or a parallel tolerance of about 1 mil, which is wanky as anything. That's really loose. So I custom designed a 3D printed cutting clamp so I can close the clamp right in on the saw blade, just to the width of the saw blade, so I know my flatness tolerance is the width of the saw blade. That's pretty much as good as you can get. Now, I've had quite a few people email me for that file. I'm making a website soon and that will be available on the website, but I will email it to you and get that over to you as soon as possible. And just on that topic, it is very likely if your ISP top isn't square that the clamp will rock on that, and that rocking clamp will end up biting the carbon where the clamp rocks at the back, and I've done a video on that, and it can cause cracks, fatigue cracks in the carbon, and eventually it can fail. So to get that cut perfectly flat and parallel is paramount, which is why you need a very, very good guide for the saw. And those Park Tool ones that you put on your steerer tube and the ISP, the gap for the saw is too big, so you can end up with a wonky line about 1 mil apart, which is a flatness tolerance of 1 mil, which is not good enough to stop that ISP rocking. On a steerer tube it doesn't really matter because you're not sitting anything on top of that cut, whereas the giant ISP, the saddle clamp is actually sat on that abutment, and you need that to be dead flat to stop the clamp rocking and damaging the carbon. Anyway, got pretty anaraki towards the end there, but hope you enjoyed that. Keep sending in the questions. You can reply down in the comments below, you can email me, or you can put it on the Peak Talk Instagram, and I'll try and get through as many as possible. And I'll try and answer as many as possible in episode number 2. Cheers.